Hello, today we're going to be studying the greatest common factor and least common multiple. You may understand this to be the GCF and the LCM, just so you know if you hear me going back and forth. As always, take notes and copy the examples. So the first thing when talking about greatest common factor, there are two ways we're going to solve to find the GCF. The first way is list method, and the second way is prime factorization method. So the list method and prime factorization. Once you've taken notes on both and have practiced both, you'll be able to pick which one works best for you. So with the list method, you're going to list all of the factors of each number. Then you're going to circle the greatest factor that is in all of the list. So if you have multiple sets of numbers, that's where it means all of the list. So for 24, I'm going to record 24, then I'm going to record all the factors of 24. And I recommend going in a relative order instead of just randomly listing numbers. So I'm going to go 1, and I know 1 times 24 equals 24. So I'm going to put 24 over there to give myself room to work my way in. Another factor is 2, 2 times 12. 3, 3 times 8. 4, 4 times 6, and then that also by having, this is also called the rainbow method, by going in an order though, you know that you're not going to skip anything. So they kind of meet in the middle, and you know that between 6 and 8 the number is 7, and 7 is not a factor of 24. I'm going to do the same thing for 42. 1 and 42, 2 and 21, 3, and again, this is where you might have to know your times tables and your divisibility rules. We'll talk about the divisibility rules later, but for right now, we're just going to figure it out. I know 3 goes into it 14 times. 4 does not go into it, 5 does not, 6 does, 6 times 7. And then that closes up for that. So so to find the greatest common factor for these, I see which one, so circle the greatest factor that's in common. So I see they have a 3 in common, they have a 6 in common. So it looks like 6, I don't see anything else that's the same. 6 is my GCF. So 6 is the largest number that both 24 and 42 have in common as a factor. Okay, so 6 is the GCF. Now the prime factorization method, we write the prime factorization of each number and circle the common prime factors. Then we multiply the common prime factors. So with our prime factorization, this is also called the factor tree method. You just find 2 numbers that multiply together to equal 24. It can be any 2 you want. I'm going to do 6 and 4. And you keep factoring it out, so 2 times 2 equals 4, until you get to prime numbers. So prime numbers are those numbers that only have 1 in itself as a factor. So right now, my prime factorization of 24 is 2, and I'm going to go in order, times 2, times 2, times 3. And I'm going to do the same thing for 42. I'm going to go with 6 and 7. 7's prime, so I'll circle it. And then 2 and 3 are prime. So 42 is 2 times 3 times 7. Again, going in order from small to large. So this time we're going to circle the common prime factors. So they have a 2 in common, and they have a 3 in common. So the GCF would be the common factors multiplied together. And as you can see, it's the same as it was on the last screen. The GCF on either method is going to be the same. So that's a good way to double check yourself if you want to do both methods. So 6 is the GCF. Now, least common multiple. So we're going to find the least common multiple by, again, using the list method and the prime factorization method. This time, we're not looking for the greatest common factor. We're looking for the least common multiple, the smallest multiple that they both have in common. So the list method, so this time, I've given you the numbers 3 and 7. You're going to list the multiples of each number. So I'm going to go 3, and I'm going to repeat that number. 3, 6, 9, 12, 15, 18. I'm going to go for some little ways and stop. I'm going to do the 7, same way. 7, 14, 21, 28, 35. So as I can see, so far I don't have anything in common. I'm going to add some more to my 3s. 21. Oh, and that reminds me, I already have a 21. So you're looking for the smallest one they have in common. So right now they don't have a 3 in common, they don't have a 6 in common, a 9, a 14, a 12, 15, 18. They do have the 21. So 21 is the LCM for 3 and 7. As you can see, the list method could be problematic if you have numbers that don't cooperate with you, if they don't have a small common multiple. So this is I would say a backup for you. I'd probably recommend the factor tree, which we're going to get into right now. So right now, for the prime factorization, we're going to prime factor each of these numbers, 9 and 15, and we're going to look at the basis and use the basis with the highest exponent, multiply by the remaining factors. So what that looks like is you take your numbers, factor them out until they're prime numbers. So I've got 3 times 3, and then I've got 15, and already we're in prime numbers. And for the purposes of this, it's always good to get into the habit of writing them in exponential form. So 3 to the 3rd power is the same as 3 squared. So this is 9. And then 15 is 3 times 5, because there are no exponents for that one. So we've got to look at the bases. Use the bases with the highest exponent. So between the 3's, 3 to the 2nd power is the highest one. So I'm going to circle the 3 to the 2nd power. And then I'm also going to circle the 5 because I've got to use the 5 still. So what that means, because there's no 5 here, so we have to use this one. So this means that now we're going to multiply the remaining factors. So 3 to the 2nd power times 5. So 3 squared is 9 times 5 equals 45. So what this means is that 45 is the smallest number that both 9 and 15 can go into. Yes, they can go into bigger numbers, but for the least common multiple, we want the smallest one possible. So 45 is the smallest number that 9 and 15 can go into. Now, putting it all together, LCM and GCF. Typically, I'll give you a problem and say, tell me the LCM and the GCF for the problem. So find the LCM and GCF. So what I'm going to do is I'm going to use the factor method. I think it's the best for you to use, and it's going to help you the most. So I'm going to factor out each of these problems. 27 is going to be 9 and 3, prime number, prime, prime. So that's going to be, okay, and 90 is going to be 10 and 9. And again, you can pick any numbers you want. I'm going 10 and 9. 5 and 2. 3 and 3. So 90 is 2 times 3 times 3 times 5. And then 84, I'm going to go with 4. 4 goes in there twice. So 21. So 4 times 21 equals 84. And again, you can use a calculator if you need to. Prime, prime. As you can see, knowing your times tables is going to be very important for any kind of speed to get these done. So 2 times 2 times 3 times 7. So remember, with the greatest common factor, you need to have a number that they all have in common, all of them. So I'm going to look through here. My 27 doesn't have a 2, so 2 is not a common factor. But it does look like 3 is. I've got a 3 here, I've got a 3 here, I've got a 3 here. And it appears that's the only thing. If they had 2 3s, then I would use both 3s, but I don't. It's just the 1. So, looks like 3, let's flip back to our GCF. So again, you're going to write the prime factorization, then you're going to multiply the common prime factors. Okay, so this time we only have one prime factor, just that single 3. So there's no multiplication needed. So the GCF is 3. Now for the LCM, I'm going to write it in exponential form. So I'm going to go over here, put 27 equals 3 to the 3rd power. The 90 is 2 times 3 squared times 5. And then 84 is 2 squared times 3 times 7. So this time with the LCM, you're trying to find the highest power for each number. So with my 2's, the 2 to the 2nd power is the highest power. With my 3's, my 3 to the 3rd power is the highest power. My 5's, 5 to the 1st power, and my 7, 7 to the 1st power. So I write that all out, and I'm going to need to get my calculator. So hang on one second. So 2 to the 2nd power times 3 to the 3rd power times 5 times 7 equals 3,780. That means that 3,000 LCM. 3,780 is the smallest multiple that all 3 of these numbers can go into. Big number, but all of these are very unique numbers. It's hard to fit them into it. So I know that's a lot of information. I'd recommend probably watching the video again, maybe another time, and then we're going to go over in class tomorrow the details.